Okay, this very first thing we're going to talk about is hopefully going to feel like a little bit of a review. And we're talking about solving systems. In other words, we are finding solutions for 2 variables. Eventually we'll use matrices to find solutions for 3 variables. But that's a little ways down the road. I'm going to show you 3 methods, 2 of which we'll go into detail on, one of which I think you probably have got. The first method I'm going to show you is substitution. Okay? You've seen this. This is something you did when you did Algebra 2, probably some work in Algebra 1, but substitution hopefully feels familiar. I think of it as the 4 S's. So solve. In other words, get a variable alone. Substitute. Right? Take that variable, plug it in, solve what you just made, and then substitute and find the other answer. Oops. Okay, so solve, substitute, solve, substitute. Let's get that fixed a little bit. Sorry, guys. Whoops. There we go. So I'm going to show you an example. However, I'm going to show you an example that uses not just linear equations. We are going to dive into some quadratics, some cubics, and that's what we have here. So, example. Anytime that I think I'm going to use substitution, I immediately organize my thinking based on, or I organize my equations based on that fact, because I think for substitution, I like to have my work a little more spread out, and I like to kind of have 2 sides, right? So I solve kind of both sides. In this problem, both equations are solved for y. So what I'm going to do is I'm going to take this first equation, and I am going to plug it in for y in the second one, right? Solve for a variable. Well, y was already solved for. Substitute. And then we're going to keep solving. So I'm substituting in. Okay. Now I'm looking at this. I got x's on both sides. Let's bring all of our x's to one side, please. And then I'm going to solve this. I'm going to solve it by factoring. You can always plug it into your graphing calculator and see what the answers are. But this is so beautiful, let's just factor it. There is an x in each one of these. So I'm going to take an x to the front, right? GCF factoring, reverse distributive property, whatever you want to call it. X squared minus 9 equals 0. X squared minus 9 beautifully splits up into x plus 3 and x minus 3. Again, it was ready to factor. That does not mean you are locked into factoring. Here's what it does mean. It means I've got a solution of x equals 0. I've got a solution of x equals negative 3. And I've got a solution of x equals positive 3. It's cubic. It should probably have 3 solutions, especially because we aren't planning on doing too much with imaginary. Everything we're going to do is going to be real, which is wonderful to hear. Now, so we solved. We substituted. We solved. Now we have to substitute up in here. Okay, so here's what we're going to do. We have 3 x's to deal with and to plug in. Y is based on those 3 x's. So I'm going to substitute 3 times. The first round, I'm going to substitute my 0. The second round, I'm going to substitute my second answer, negative 3. My third round, I'm going to substitute positive 3. Okay? Every time I do that, I get a new answer for y. Okay? And what I mean by that is when x is 0, y is 0. When x is negative 3, y is negative 9. And when x is positive 3, y is positive 9. Okay? That's substitution That's substitution a little bit on steroids compared to what you did in Algebra 1, but it's still good. Substitution is a great, great method, and I hope that you can kind of piece this together. The second method we have is elimination. This would not be good for eliminating. Well, it wouldn't be terrible because we've got x to the third minus 6x and then just another x over here, but we probably are going to use elimination when it's set up really nicely for that. And what I mean is when I've got two equations that look super similar and can easily stack. So let's talk elimination. The biggest piece in elimination is we are going to make opposites. We're going to make opposites of one of our variables so that when you add them together, it cancels out. In other words, if I've got 5y and negative 5y, the y's will cancel, okay? Or if I've got 3y and negative 3y, they'll cancel, right? That's what I mean by opposites, 1 plus, 1 minus. We're going to solve. We're going to substitute because we always have to find x and y. And we're going to solve again. Example. I'm going to take you out of your comfort zone a little bit. I think we kind of know how to do elimination when it's just like 3x plus 5y equals 10, 3x minus 5y equals 32, stuff like that. So I'm going to make you a little bit uncomfortable. And I'm going to ask you to eliminate something like that. Some of you will immediately say, hey Visto, look, the x squareds are going to go away. And I'd be like, ooh, that's great. But the x to the third doesn't. And to use elimination, we have to make both things go away. So instead, I'm going to cancel the y's. And here's how I'm going to do it. I'm going to multiply by negative 1 on this bottom equation. Top equation looks good the way it is. So I'm going to leave the top equation the way it is. Now look at what my y's have done. I have positive 1y and negative 1y. And I am going to now eliminate the y's because they're opposites. And when I add them together, they cancel each other out. So here's what I mean. We're going to add. Y plus negative y is 0. Now again, multiple ways to solve this. Here's what I'm going to do. Greatest common factor of x squared. Pull that to the front. And then after that, it doesn't factor anymore. So my solutions are x equals 0 and x equals negative 2. That's my solutions for x. To get my solutions for y, I gotta come back over here. Since I have two x's, I'm going to get two y's. Okay? The first round, when I plug in 0, 0 squared is 0, negative 0 is 0. That's kind of boring. In the second round is where it gets cool. Negative 2 squared turns to positive 4. Positive 4 when I make negative flips to negative 4. So my final solutions here are 0, 0, the boring one, and negative 2, negative 4. Okay, that's our second method. Solving with elimination. Now, was elimination the best method here? I don't know, probably not. Was it fun? I thought so. But know that it'll be pretty obvious when elimination is a good method. Because chances are you'll see everything stacked up nice and neat, and it'll be ready for you, I guess is the moral of the story. Third method, graphing. Okay, graphing is super high tech. Plot both equations. And I say plot, I mean get your 84 out, or get your Desmos out, or you do you, boo, but that's what I mean. And see where they cross. Wherever they cross, there's your answer. Okay? Now, there are two special cases that we have to be mindful of. The first one is sometimes we're going to get no solution. In terms of lines, that means you have parallel lines. They don't ever cross, right? It literally says, see where they cross. If they don't cross, we have no solution. If we're doing solving, no solution happens when the end result is a contradiction. Contradiction means the math doesn't make sense. Your work makes sense, you're a star, but the math doesn't make sense, or the answer doesn't make sense. So we get like 0 = 8, which is not anything in math land, it's a contradiction, right? On the flip side, we can have infinitely many solutions. That just means your two graphs are exactly the same. They cross infinitely many times because they basically just live right on top of each other. In terms of solving with substitution or elimination, that just means the end result is an identity. The two numbers are exactly the same on each side of the equal sign. So, lots of information on solving, kind of what methods and what we have and what we can use. Take a look at it, do some examples, let me know if you get stuck. You're going to be great. I know you will.